Welcome to day 2 of Properties of Logarithms. This is still from your worksheet 7.5, Properties of Logarithms. Let's start on the back side. The first problem on the back side, number 17, says evaluate each expression. In order to evaluate these, you understand your properties of logarithms and use that and evaluate it in your head, or you can also use the change of base formula in order to evaluate expressions. So change of base means that we're going to change both of the things to base 10, and we can evaluate it by doing a quotient. So to use the change of base, we're going to rewrite this as a quotient, and we're going to use base 10 for both of them. Now you can use a consistent base, but we use base 10 because then we can do that on our calculators. So I'm going to rewrite this of base 10 of y, and then over log base 10 of my b, my base. So here I'm going to rewrite this as log of 16, and remember that when I don't write the 10 there, it's automatically there, all over log of 4. Again, so when we change them so that they're both base 10, and I'm dividing y by b. When I punch this into my calculator, log base 10 of 16 divided by log base 10 of 4, I'm going to get 2. Now that should make sense, and you should be able to kind of do this one in your head anyway, because 4 to what power is 16? Well, 4 squared is 16. So then you can kind of check your work. Let's now take a look at problem number 25. Problem 25 says your classmate went to a rock concert. At the loudest point during the concert, the sound had an intensity of I equals 10 to the negative 3 power watts per meter squared. What's the loudness in decimal of this sound in decimals? Remember that decimals, the equation is 10 times the log of I over 10 to the negative 12 power. So really for me, this is they're giving us what I is, and they just need us to plug in I into the decibels formula. So I'm going to rewrite this, plugging in I. So it's 10 times log of 10 to the negative 3rd power over 10 to the negative 12th power. Now, we just did a ton with exponents, so I know my exponent rules really well. And when I have a quotient with the same base, I can subtract my exponents. So I'm going to do that. I'm going to have negative 3 minus negative 12, which really becomes negative 3 plus 12. Negative 3 plus 12 is 9, and so I get times 10 to the 9th power. Now I can use my calculator to help me calculate this, 10 times log of 10 to the 9th power, and I find out that this is about 90 decibels. If you have any questions, please see me, Mr. Daniels, and have a fabulous time doing the rest of the worksheet.